3.6 Compound inequalities. Basically, compound means to put things together. So we have compound inequalities, and there's basically two types. There's the or and the and. So first, the or means that the inequality must be true for either one, and what you have is that they actually will go away from each other if you've done the problem correctly. So what are the solutions of 3t minus 5 less than negative 8, or 2t plus 5 is greater than 17, and graph the solution? So the first thing we do is we take 3t minus 5 is less than negative 8, solve it algebraically, add 5 to both sides, then divide both sides by 3, and then this will give us t is less than negative 1. Then we go on to solve the second problem, so the or part is we have 2t plus 5 is greater than 17. We then subtract 5 from both sides, getting 2t and 12, and then divide by 2 to say then that t is greater than 6. We didn't have to worry about multiplying or dividing by a negative, so the signs stayed where they were. Now we combine them together on the same graph. So I sketch a graph with the negative 1 and the 6, and I want to use my key point of 0. So to test this, I want to plug in 0 to the first equation to get 3 times 0 minus 5 is less than negative 8, and then I get the statement negative 5 is less than negative 8. This is a false statement, so for whenever I had negative 1, I want to shade away from 0. And then for the second one, I have t is greater than 6. I plug 0 into that equation as well, and then this is going to give me 5 is greater than 17. Again, this statement is false, so again, I'm going to shade away. So this is an or inequality, and what you should have is the two arrows shade away from one another. The next example is going to be an and inequality, which means both inequalities must be true, and think of it as between. So what we have then is the shaded region falls between the two, and it's kind of tough to see on that graph, but you'll see with the example. So what are the solutions of 17 is less than 2x plus 7, which is less than or equal to 29? Notice that it is between, and we would say it is both statements. So first we take 17 is less than or equal to 2x plus 7, solve that algebraically, subtract 7 from both sides, and then we're going to divide by 2 on both sides, so we get 5 is less than or equal to x for our first expression. Since it's a between, we call it an and statement, and now we have to solve 2x plus 7 is less than or equal to 29. We're going to subtract 7 from both sides, and then we have the 2x is 22, and then divide both sides by 2 to here get x is less than or equal to 11. So again, we're going to sketch a graph. We're going to put both 5 and 11, and 0 is off to the left in both of those situations. So we plug in 0, and we get the statement for the left-hand side of 17 is less than or equal to 7. For this one is a false statement, so for 5, we're going to shade it in because we're including the value, and we're going shading away from 0. So now for the next one, we have plug in 0 for the other equation, and this is basically going to result in 7 is less than or equal to 29. So here this is a true statement, and in this case we shade towards. Notice that we fill in between and we do not include arrows.